Hello class, welcome once again to E523 class this morning, Radio and Television Engineering. Let me just go straight to the first topic we have, which is radio wave propagation. Radio wave propagation. What is radio wave propagation? Radio wave propagation refers to the way radio waves travel or propagate when they are transmitted from one point to the other, that is from the transmitter to the receiver end, and the way they are affected by the medium in which they travel, and in particular, the way they propagate around the Earth in various parts of the atmosphere. You agree with me, or recall that the atmosphere is divided into different layers, and there is always a need to transmit or propagate signal or information from one point to the other, at times through the various layers of the atmosphere. So the way the atmosphere itself interacts with the propagated wave or signal is what generally referred to as radio wave propagation. Another way, more precisely, is to say that radio propagation refers to the behavior or attitude of radio waves as they travel or as they are propagated from one point to the other or into the various parts of the atmosphere. In the atmosphere, we have the biosphere, we have the hydrosphere, we have the troposphere, we have the ionosphere. But of course, the most important of these layers of greater importance to communication engineering is the troposphere and the ionosphere, which we shall see later on. So this is what radio propagation actually connotes: the way radio waves behave when they are being propagated on their journey from the source to the destination. Now, we have talked about radio waves, radio spectrum. Radio spectrum is the part of the electromagnetic spectrum with frequencies from 30 to 300 gigahertz, 30 hertz to 300 gigahertz. You recall that we have the electromagnetic spectrum, which spans from very low frequency to the tremendously high frequency. From very low, extra low frequency rather, to the tremendously high frequency, or some materials will call it extremely high frequency EHF. So there's a particular portion of that EM spectrum that is dedicated to radio wave propagation. That is the radio spectrum. Electromagnetic waves in that particular frequency range, what are called radio waves, are commonly used in telecommunication engineering. They are mostly used for telecommunication purposes, propagation of radio waves, a lot of them like that: Bluetooth, microwave, TV broadcasts, radio broadcasts, and lots like that. They all form what we've grown as radio spectrum. Now, from the radio spectrum, say they are also distributed into various bands, from the extremely low onto, that is, to the tremendous, as I said, radio frequency bands. We have the ELF, the infra low, the very low, the medium, up to the extremely high frequency. That's the gigahertz range, and the tremendously high, that's 300 gigahertz to 300 gigahertz to 3 terahertz. Those are the bands of frequency for radio wave propagation. As I said, they all form a part of the entire electromagnetic spectrum. We have the visible light, we have the microwave range, we have the radio frequency range, we have the millimeter wave. All these are components, they are sections within the electromagnetic spectrum. So we are particular about the radio frequency in this particular course we are on. We're talking microwave as well. Microwave range is part of our discussion, and then radio frequency as well. Now, propagation. Talking about radio is propagated from the transmitter to the receiver, or from the source to the destination. So we have different mechanisms for propagation of radio wave, for propagation of radio signals. The first is a ground wave, which is actually a kind of signal that moves along the curvature of the Earth. Look at this figure. If you look at the figure, it's talking about there's a receiver, there's a transmitter, and then there's a wave that moves along the surface of the Earth. That's the ground wave propagation. You can see from the receiver, the distance between the receiver and the transmitter is called the skip area. The skip area. So you can see the wave actually, the wave has a tendency, the wave that being propagated has a tendency of being affected by the permittivity of the earth, by the dielectric of the earth as well, because the moves along the surface, it moves with the curvature of the earth. That is one of the mechanisms for propagating radio waves. The second one is the sky wave. Is the sky wave. The sky wave is actually is beyond the earth now. It's really used for they call it beyond the horizon propagation, or beyond the horizon communication, like from one part of the earth to another part of the earth, making use of the tropos of the sky wave, which is also called the ionosphere. The sky wave propagation is also called the ionospheric propagation because the signal is propagated from temperature into the atmosphere, particularly into the ionosphere, where there are ions. The ions that are within the ionosphere, cause the signals to be affected, either to be reflected or to be refracted, depending on the permittivity of the signal that's being propagated. Because what engineering is trying to do is to use nature, natural phenomena of the sky, or the ions within the ionosphere, to assist in propagating radio waves, to assist in transmitting the signals from one part of the earth to the other. If you look at this figure, there's a transmitter here. At this end, there's a receiver. This is the Earth's surface. This is one part of the Earth. This is another part of the Earth. These are different layers of the ionosphere, of the sky wave. That is, you have the G, the E, the F1 and F2 layers. These are ionospheric layers. Okay, by the way, the ionosphere is about 400 kilometers from the Earth's surface. About 400 kilometers from the Earth's surface. So that is the different layers of the ionosphere through which the signal will pass through. And then look at between the ear, you can see there's a refraction here into other part of the earth. So what you are sending here is being received at this other part of the earth with the aid of the ionospheric propagation. Although, permit me to say here, the advent of the internet, the advent of the satellite technology has actually caused a lot of reliance on satellite over these mechanisms that are talking about, the ground wave, the sky wave. So there's much reliance, more preference for internet propagation, satellite radios, like that, satellite TV today as we speak. So these ones, they are still there, but there is more of dependence, more of choice for the internet-based technology, internet-based propagation, as we may want to say. Now, apart from the ground wave, there are other forms of waves that, from transmitter to this. For example, there's what they call the direct wave. Direct wave is a signal from transmitter to the receiver, from transmitter antenna to the receiving antenna. So we have the direct wave. We also have the ground reflected. The ground has the tendency to reflect as a to reflect the wave that's being propagated from the transmitter towards the receiver. So we have the ground reflected, or you call it indirect wave. So we have the direct wave, we have the ground reflected. It's a wave that's reflected from the ground towards the transmitter. So we have the ground wave. So we have the ground wave. Okay, the ground wave is also the, as I said, the ground wave or the surface wave. So you can see that different kinds of mechanisms along at the ground level. At the ground level. So we have the ground reflected, and we have the surface is also the ground here. We also got the space wave. The space wave is actually the sum of the ground reflected and the direct and the ground reflected, plus the surface gives us the space wave. I can see, look at the figure from the sky wave up like that, the sky wave, the troposphere, look at the ionosphere. So I was saying earlier, this figure is trying to go all the mechanisms together in one diagram, all the together in one diagram. Then the next one is the troposphere. Is responsible for allowing over the horizon VHF and UHF communications to ranges approximately 300 miles on a regular basis. It's kind of this one happens just before this, about 10 kilometers or 12 kilometers, between 10 and 12 kilometers from the Earth, is where tropospheric scattering actually takes place. It's another way, it's different from the atmospheric propagation, because it involves kind of like a turbulence, like it causes kind of a scattering when waves signals reach the tropospheric level of the atmosphere. So this is what briefly I want to talk about regarding radio wave propagation. I have the materials I've sent to you in your Google Classroom space. So please check it out and read more on your own. At this point, let me call it a day for this class this morning. I hope to see you in class next time. Thank you and stay blessed.